Hi there. In this video, I'm going to show you how to interpret some of the charts that you'll see when you use some of the models in Analytics Solver. In this chapters 4 and 5, you're just being introduced to the concept of testing and training data so that we avoid overfitting, and also some of the ways that we evaluate that predictive performance. So this data set I have here is a bankruptcy data set, and you can see on the current spreadsheet that we're looking at, the first attribute that's described is called D, and that's our outcome variable that we're trying to predict. So D equals 0 means the firm failed, and D equals 1 means that it's a healthy firm. And then we have a number of attributes here that are numeric in nature, also called continuous, sometimes in data mining literature. And these are going to be our independent variables that will hopefully tell us how to predict whether or not a firm is going to be successful or not. So going over to the data itself, you'll notice over here that I have this data set that starts with the outcome variable of D, and then it has all the other data along with the actual values for each record. So as you've learned in chapter 4, it's very important to divide our data into training and testing data prior to actually applying an algorithm. So that's the first thing that we're going to do. I'm up here on the data mining tab in Excel, and then I'm going to go to partition and standard partition. And then I need to tell it which attributes I want to include for partitioning. So I'm going to include all of them and bring them over here. It's going to split it into 60% training and 40% validation. So it's going to use the training set to actually build the model, and then it's going to test the results on the validation set. In this particular problem, we're not also doing a test set, which you've learned we sometimes also add an additional layer of testing. But for this simple explanation, I'm going to just use a 60-40 split and click OK. And then what it's going to do is it's going to create another spreadsheet for me. And now it's going to have the data partitioned into training and validation. You can see up here, here's the summary. I have 79 trading records and I have 53 validation records. I'm going to click anywhere in this table, and then I'm going to apply a classification algorithm called classification tree, or a decision tree, which you'll be learning about in a few weeks. The first thing I need to do is tell it which variables I want and what places. So the output variable for this problem is D. So I'm going to move that down here, and oops, I'm sorry, I put that in the wrong place. I'm going to move that back. I'm going to go down here and put it there. And then the next thing, it divides it between selected variables and categorical variables. Our data is all continuous or numeric, truly numeric data, which you'll also be learning about all the different data types we have. Sometimes categorical data is coded numerically, but it's still categorical. So for instance, marital status may be coded as 1 is married, 2 is divorced, 3 is single. Even though it may have numbers there, it's truly, we don't treat it like a number in data mining. So, but in this case, we really do have numbers for everything else. So I'm not going to include record ID because it's not a meaningful attribute. But I'm going to include everything from year all the way down to R24, and I'm going to put it over in selected variables. It's already figured out that we have two classes, meaning that 0 is bankrupt, 1 is not bankrupt, and I'm going to go to the next page. And from here, I'm going to show which tree I want, which I'm going to choose fully grown, and we'll learn more about pruning and some of the other things that you can do in here to help your results. But for now, let's just keep it simple. And then I'm going to go to next, and I'm going to choose lift charts, detailed, and lift charts for both the training data and the validation data. And then I'm going to click finish. You'll see now I have a number of new spreadsheets that just came out. So I'm going to just scroll over a little bit. And I want to get to, there's both a training lift chart and a validation. I'm going to look at validation here. So you'll notice we have 3 charts that popped up. One is called an ROC curve. The other one is called a decile-wise lift chart. And the other one is a lift chart. And how you interpret these is a little bit different for each. So starting on the right-hand side here with the lift chart, you'll see that we have this red line coming down. That is the baseline that we're using, and that's just saying just randomly, if we were just randomly create a model, what would it look like? And that's the line that we use. The blue line is our actual model results. What you want to see happen with this is you want to see this blue line move as far away from this red line as possible to the left. You can see here that there's some times where the blue is actually over to the right and over here, so they're showing some, its predictive efficacy is not quite as good as it could be. Same thing over here with the ROC curve. This is testing sensitivity, which is true positives versus false positives over here on the bottom. You want to see this blue line as far over to the left from this red line, meaning the random classifier. And the more space you have in between the red line and the blue line shows that there is a pretty good model going on. And then the next thing I'm going to look at is this decile-wise lift chart. So you'll see here, you've kind of, it looks like it's all over the place. So let me just pull up a website here to show you. If we go down to this website that I have, it's showing this kind of what they call the ideal decile chart, which it says it should have that staircase effect, meaning gradually descending all the way down across the sections. And these are the first one is the top performing and then moving on down. If you see something like this in the next one, this is showing that your model's not doing a really good job of predicting. So you want to probably look at what you've been doing with your analysis, maybe looking at your data, maybe looking at skewness of various variables, maybe doing adding a test portion to the test as well as the validation. So there's a number of different ways what this will tell you. So this is just but one data point in looking at the results. Going back here, the other things you can look at is the scoring. And I have another video that will tell you how to actually get the accuracy and error rates from the confusion matrix that's here. Here they're actually giving it to you. So you'll see here, this is the confusion matrix showing the diagonal line between here is showing what was accurately predicted across the two classes. And then over here, it's actually creating the accuracy. So the accuracy for this particular model is 70%. It's not horrible, but it's not great. And as you can see, also looking at those lift charts, that it could be better. So there is some issues in this data that we would need to look at further to figure out why it's not quite as good as it could be. The other thing you can look at is looking at the training score. And you'll see here the training is at 100%. And you can see that the confusion matrix is showing that there's zero misclassification going on in this training model. So we have overfitted our data, and so it's not able to accurately characterize and model in a full population. And the lift charts, I'm sure, are going to show, they're going to look really, really good. So here we go. Okay, so this is a staircase, but it's showing that it's doing great and then drops. Here you can see the blue curve is all the way over on the left side. It's doing fantastic. And then over here we have a lot of really good space in between the red line, the baseline, and the model. And so again, there's no blue over on the right side of the red line. So this is showing that the training, it was able to build a model to 100%. But when it got to validation, it struggled. So this would mean that we would probably need to go back and do some more work. So this is how you do use these charts in evaluating your models when you get to this point. I hope this video helps clarify some of the metrics we use in data mining.